In section 1.8, we look at point-slope form of the equation of a line. We're going to write linear equations in point-slope form given the initial value and the average rate of change. We're also going to write the equation of a line with 2 points if one of them is the vertical intercept, and generally 2 points if neither is the vertical intercept. Additionally, we'll compare the slopes of vertical or parallel lines, I meant to say. Starting out in this situation at the top here, we are going to buy a new camera that costs $1,200. We're going to make a 20% down payment, and then we're going to pay the rest of it in 24 equal monthly payments. So the down payment required is going to be 20% of $1,200, which would be $240. And the amount I owe after I make the down payment would be $960. Then my monthly payments, since I have 24 of them, would be $40. All right, so continuing on, I decide I can afford $40, so I go for it. What is the amount A? So the total amount paid is going to be A, and that's going to be a function of the number of payments made. So the amount A, what is the amount I've paid when n is equal to 0? So when I've made no monthly payments, all I have paid is this down payment. So my A value would be $240. After I've made one payment, my A value, since I'm making $40 payments, would be $280. And after I've made two payments, I would be at $320. So we can fill those values down here in our table. 0, 240, 1, 280, 2, 320. Next, we want to compute the average rate of change from n equals 0 to n equals 1, so over this first set of points right here. And our average rate of change is the final amount minus the initial amount over the final payment minus the initial payment for that set. So 280 minus 240, change in output, over 1 minus 0, change in input. So that's 40 over 1, which is 40. All right, now we're going to compute that again, this time looking at the average rate of change from n equals 1 to n equals 2. So these two. And again, we are going to compute this with final output 320 minus initial output 280, final input 2 minus initial input 1. If we compute that difference, 320 minus 280 is 40, over 2 minus 1 is 1, is 40. All right, and now what type of function is this? Because we are getting the same thing for both of these, we can conclude that this is going to be linear function because it has a constant rate of change. All right, now we want to continue on and write the equation. So this note here at the bottom says that recall to write an equation of the form y equals mx plus b, a linear equation, we need to know the value of the slope m and the vertical intercept b. We're going to flip on to the next page here. What is the slope m? Well, the slope is the same thing as the average rate of change. We just computed it twice, so we know that it is 40. And then we actually know the vertical intercept as well, the initial payment. The initial payment is from this ordered pair that has 0 as the input. So our B value is going to be 240. So back over to our next page. Our B value is 240. Remember, the B value is always in an ordered pair that is 0, B, and so since I was able to identify where 0 was as the input, B must be the matching output value, must be 240. So together, I put these into y equals mx plus b, or in this case, we're going to name the dependent variable a and the independent variable n instead of x and y. So we'll make our function a equals m, which is 40, times n. plus B, which is 240. All right, so now we're going to graph the equation. I like to do our graphs on decimals instead of on paper, so I will move mine over and make it just a little bigger. Okay, so graphing our function a equals 40n plus 240. At first, we're not able to see very much of this graph because the window is so small. So we're going to manually rescale this one. It does say in the book that we want to graph this for n values between 0 and 24. So if I manually rescale, I'm going to use my graph settings. I'm going to change the n, which is the independent or x variable, from 0 to 24. And then, again, I can't see anything in this window, so I'm going to modify the y-axis, and I'm going to guess on this. I know that my payment shouldn't go below 0, so 0 seems like a nice minimum value for y. I know the initial payment was $240, so I'm certainly going to need to have payment values that go from 240 and get larger. So I would guess, say 500 to start, and we'll notice I'm not high enough because I've only gotten into the 7th month or so by that 500 marker. So I would maybe now guess to try, I didn't mean to do 10,000, to 1,000, and we're getting pretty close to the mark right here. We can't quite see 20, so we can make it marginally larger if we wanted to see all the way out to 24. So I'm going to go up 1,200, just another guess right here. And that seemed to be pretty nice because it's matching up with our 24 right there in the corner. Once you properly scale the graph, you can zoom in and out, but again, if I zoom in or out, it's going to change the settings that we have on the axes. So right now I can see this graph from 0 to 24 across the bottom and from 0 up to 1,200 on the top. Okay, so that is my picture. All right, so if you would like, you can draw this picture in your graph on the page. I'm just going to look at my decimals graph and then move on to the next question. All right, let's move this over to the side. The next question asks us, what is the slope of the line graphed? What is the practical meaning of the slope? Well, I already know that the slope of this line is 40 because that was declared up above. But the important part of this question is, what is the practical meaning of the slope? So looking back at our input and output, the output is the amount paid. We always start with that. So the output, the amount paid. And then what kind of change is it? So is it increasing or decreasing? 40 is positive, so it's increasing. Then by how much? By 40, and 40 needs its units. So by 40, the amount paid is in dollars. So I'm going to put my dollar sign there. And then we need per, and we need our units on the input. Units on the input are payments, so per payment. So the amount paid is increasing by $40 per payment. Okay, what is the vertical intercept? Write the answer as an ordered pair. So when we had mentioned it up above, we had just given the B value. Remember, the B value is one part of the vertical intercept. So the vertical intercept itself is 0, 240. And then the practical meaning of this point, we want to give both the meaning of the x coordinate and the y coordinate. What does the 0 mean? What does the 240 mean? So the 0 means that initially, or as the down payment, we paid $240. So initially, or the down payment, was, and with units, $240. All right, that ends the camera example, and now we're going to look at example number 4 here. This one's about students at a college. There were 1,100 students in 1994, and then there were 1,940 students in 2018. Okay, we want T to be the year, that's going to be our input, and we want N to be the number of students, that's going to be our output. So first of all, we should be writing 2 ordered pairs. And because the inputs are year values, we almost always want to count years since or years after something. So in 1994, we're counting after 1994. So 1994 is going to become our 0th value. and the output for that's going to be the 1,100. We never want to use a full year value like 1,994 or 2018, because if you were graphing this, you'd have nothing on your x-axis for a very long time until you reached 2000. And so your graph would have this big void in it. And we want to just avoid that big void and move things closer to the origin by resetting what we count from. So we're counting from 1994 for our years here. So my next ordered pair, 2018. So if I count from 1994 to 2018, that's going to be 24. If you can just subtract that, 2000, I'm going to make a note over here, 2018 minus 1994 is 24. So my next ordered pair is 24, 1940. All right. Complete the table. Okay, so for 0 as an input, 1100 or 1100, and then 1940. What is the initial value of this function? Recall that if we have a 0 for our input, then the initial value is the b value is the 1100. It is the value that corresponds to the initial of 0. So I know the b value right away. Okay. I don't know the average rate of change yet, but we can compute this. So we will do that. Change in output. So our 1940 minus our 1100 over 24 minus 0. So change in output over change in input. All right. Now I have my decimals graph open, so I'm just going to compute that here. We can hit the fraction, the division key. It's going to pop our fraction up. We can just go ahead and type the entire quotient in. And we're desiring a decimal result anyway, or a whole number. It came out as 35 right here. So we'll just type that whole thing in. In the contextual examples, we would prefer a decimal or a whole number rather than a fraction. So we'll just type it in. All right, so the average rate of change is 35. Is this constant? Now, I don't have a way to prove that it's constant like we did in the other example where there were two different sets of ordered pairs and I could show that I got the same thing. So hopefully somewhere in the description of the problem, they have relayed that information. So if I go back over here, it says that the number is increasing at a constant rate. So they told me that it was going to have a constant rate, and therefore I know that it has a constant rate. The information has to be provided for me to be able to make the assumption in this case that this one should be linear. So yes, we were told that it was. We're told that it's constant. All right, so now we get to put these together to make the function. Y equals mx plus b is the general form, and we're going to just change the variables from x and y, which are the generic variables for input and output, and we're going to be using n for the output and t for the input. So n equals m, which we have just discovered, that's our rate of change, is 35, times t plus, on our previous page, we had said that b, the vertical intercept, was 1100. All right, so we're practicing writing these equations here. We're going to take a look at the next situation and practice again writing the equation. To be able to write the equation, we need to discover what I used the wrong letter in accident, what m, slope, and b, vertical intercept are. We're looking for those two pieces. If I know m and b, I can write the function. All right, so next scenario, we have a student taking 6 credits and it costs them $1,520, and 9 credits cost $2,255. So ordered pairs for these, we're not doing year since, so I don't need to modify. I start with 6 credits as independent, $1,520, and then 9 credits or $2,255. We can organize this in ordered pairs or we can organize it in the table. Doesn't really matter. Right now they're asking us to organize it both ways. So table and ordered pairs, same information. Determine the average rate of change. All right, so I have change in output, so final output minus initial output, and divide that by final input minus initial input. And again, I'm going to use Desmos to help me with the calculation part here. So I have my quotient of output over in, oops, I mistyped that one there. Okay. And change in input would be our 9 minus 6. So this one comes out as 245. All right. So we're going to interpret the average rate of change. We didn't get to do this last time. We didn't interpret it. Interpreting is that sentence again. The output is changing how and by how much and how often. So the output, that's total cost, is what is it doing? Increasing or decreasing? This is positive, so it's increasing. By how much? By 245, and then units. Units on cost are dollars, and then how often? Per number of credits, so per credit. Right? So we need what is the output, what is it doing, how much, and how often. So we need the output units per input units. Is the rate of change constant? Again, I only have one ordered pair to work with, so I can't do it again with a different ordered pair and check that I'm getting the same thing. So I have to be told. So back up here, if I read through this more carefully, we see that yes, it does mention that we have a fixed tuition amount per credit. And so that is what we're going to explain for why it is constant. Again, they told me it was constant. So yes, because we have that fixed tuition per credit. And the fixed tuition per credit is $245 per credit, as we've just discovered. Okay, so I know my average rate of change. So I know M. M is 245. I don't know B because neither of these inputs are 0. So I don't have that information given to me automatically. I don't have an ordered pair with 0. So we're going to need to find B. So we're going to take our base form of the equation. Again, it would be y equals mx plus b. However, we are going to call the dependent variable c for cost instead of y, and we're going to call the independent variable n instead of x, n for number of credits. And again, these can go in either order. Remember, it can be mx plus b or b plus mx. In this case, they have the mx separately. I don't know why it's on the other side. It doesn't really matter though. But I don't know what B is. So what they said is go ahead and just put M in for now. So C equals, I don't know B, plus M, which I have discovered is 245, times N. Okay, so next we need to find B. And so to help us find B, they're walking us through the steps here. They say take the ordered pair, plug it in for input and output, and we're going to solve for B. So it doesn't matter which ordered pair actually, so I could choose. I'm going to use the one that they have suggested. It does not matter which one. Either one will get me the same result for B. So 6 is the input, 1520 is the output. So I'll have 1520 equals B plus 245N. All right, the space to solve that, sorry, it was down at the bottom there. The space to solve it's on the next page, luckily, so I can switch over to my next page to continue to solve this. So let me write it up here on top. What we just said was 1520 equals B plus 245N. We want to solve this equation for, 245 times 6. I might have forgotten my 6 there on the other page. I'll have to go back and look. But remember, the ordered pair had 6 as an input and 1520 as an output. So I was definitely supposed to put in both of those numbers, 1520 as the output, 6 as the input. Now I'm going to solve for B. So I need to figure out what 245 times 6 is. I do not know, so I'm going to multiply them. 245 times 6 is 1470. So now I have 1520 equals B plus 1470. And then to solve this for B, we're going to subtract 1470 from both sides. And that gives me, get my mouse in the right spot here, that gives me 50. Okay. So our B value is going to be 50. Interpret B. Okay, so we're going to interpret this value for B. Remember that B is half of the ordered pair 0, 50. So when I make the interpretation, I need to talk out what the 0 means and what the 50 means. So the 0 would be 0 credits. If I took 0 credits, I would still have to pay $50. So I'm paying this $50 on top of the credits. I'm paying that even if I have to take 0 credits. So this must be a course fee or a registration fee. So we can infer that there is a fee of $50. Okay, $50. So for 0 credits, I'll write that part in parentheses. Just saying there's a fee of $50 is sufficient because it assumes that there's no credits being taken. That's just the fee that you would pay on top of your tuition cost per credit. Finally, rewrite the equation with both M and B. So we had already stated that it was of the form C equals B plus 245N. Remember, we already knew what M was. Now we're going to put the number in here for B as well. So C equals 50 plus 245N, and that is our finished equation. So we had to do a bit more work to find this equation because I did not know the vertical intercept from the beginning. But we can discover it by using one of the ordered pairs in place of the input and output and solving for B. To do that, though, I do have to know slope first, but with 2 ordered pairs, you can compute your slope. All right. There is an alternate way to do the same process without using a different formula, I should say. There's an alternate way to get this same result using a different formula. So we're going to do this again, the same question again. Our goal is to get the same answer again, but this time we're going to use the point slope form of the line. The point slope form of the line is y equals y naught. That sub-zero is read as naught, N-A-U-G-H-T, y naught, or initial y, plus m times x minus x naught, or initial x. So in this formula, m is still slope, of course, and then x naught, y naught is a ordered pair. So this would be your initial ordered pair. And then x and y, of course, are the letters. And we may be using N and C because those were the letters for this context. All right, so there's an example one that shows us how to do this. We're going to go ahead and take our book down here to number 7. We're going to use this same ordered pair for the initial, for x naught, y naught, or c naught, n naught, c naught. And we're going to use our slope of 245. So if I start my function, the equation would have output, which is c, we're calling output c in this case, equals initial output, which is our 1520, plus m, which is our slope, 245, times x, that's our input variable. Our input variable is called n, minus x naught, which is our initial input. Our initial input is 6. Okay. I'll transfer this to the other page where we can continue the simplification. So up here on top, so far we have c equals 1520 plus 245 times n minus 6. So I want to simplify this. So the first thing I need to do is distribute the 245. So c equals 1520 plus 245 times n. minus 245 times 6, which is 1,470. Now we're going to combine like terms. On this side, we have like terms. We have 1520 minus 1470. And if we do that computation, 1520 minus 1470 is 50. So that gives us 50 plus 245n. And so we get our solution. We have the same thing that we had on the other page for the equation. Again, you can compare the equation on both of our pages. So pros and cons. I guess they want me to repeat it first, and we can talk about pros and cons of this one. They want us to make sure that we get the same thing for the other ordered pair. So again, C equals, in place of y naught, if I'm using the other ordered pair, I would have the 2255 plus my slope, which is 245, times n minus 9. We're going to do the distribute here. So still have the C equals 2,255 plus 245n minus, I need to figure out what 245 times 9 is. So 2,205. And now again, we are combining our like terms here, subtracting 2,255 minus 2,205, and that gives you 50. So we have 50 plus 245n. So illustrating that it actually doesn't matter which point you choose to use, which point you choose to be your initial point, you get the same equation regardless of the point. All right. That's what we're saying we demonstrate down here, right? So again, I just want to mention that I can find this same line. I did it 3 different times now. I can find it using point slope form, which is the one we were just doing, or a slope intercept form, which is the one we did prior. The advantage of point slope form is that you get the equation directly without having to find b and then sub it back in. So this one's more direct to get the equation. The disadvantage is that I have a second equation that I have to remember. With the first method, it's all mx plus b or b plus mx. So I am using the same equation that I may already remember, but I do have the additional step of putting the b value back in. So there's a benefit and there's a pro and a con to both methods. You can decide whichever one you would prefer to use. Doesn't matter to me. All right, so we get a little bit more practice here with number 8. We're going to use point slope form to write the equation for this scenario. I have to first find slope. Okay, so change in output, final output -2 minus initial output 4 over final input 5 minus initial input 2. So that gives me -6 across the top and 3 across the bottom for a slope of -2. All right, point slope form, it says use this point. So I can use either one. If I were to choose, I would choose this point anyway because the coefficients are, numbers are positive, and so I won't have as much potential error with a negative involved. So we'll just use this point like it says. So y minus the y value in the point we've chosen, which is 4. I'm sorry, they actually put that on the other side. There's another form that has the minus. So y equals, apologies, y equals y naught, which is 4. Plus m, which is -2. So I actually could make this just -2 times x minus 2. Now we're going to do our distribute. So I have y equals 4 minus 2x and then plus 4. Add up the like terms. Y equals 8 minus 2x, or you could have written the -2x first and the plus 8 second. That's how I tend to write mine. Just putting the slope first, doesn't matter, gives you the same line. Now I want to check this one just because I can. So back over here in decimals, let me just go ahead and make a new graph. I'm going to plot the 2 ordered pairs that we started with first. We started with the ordered pair 2, 4, and we had also the ordered pair 5, -2. And our answer that we came out with was y equals 2x plus 8, which should go right through the 2 points, and you can see that it does. So it shows us that the equation that we found is the correct equation. All right, coming down to our last objective for the section on parallel lines here. We've got a situation where we're talking about that camera again with the A equals 40n plus 240. Now we're considering ordering a tripod, and the cost for the tripod is $160. We do not want to increase our monthly payment, so we want to add its cost to the down payment. So what will be the amount of the down payment if we add the tripod in? So it already was prior to this $240, and now we're going to add on that $160. So that's going to make it $400 for our down payment. Okay, so write the linear equation that gives the amount paid. Remember, our amount paid per month is unchanged at $40. So A equals, it's 40n still, but this time plus 400 because our down payment has increased. Okay, so graph this new equation on the line below. I'm gonna I know that it begins at 400, so 250. What is this kind of a 125? So that would be 375. So 400 is just above there. And it's going to be kind of hard for me to graph this exactly. So I'm going to try, and I'm going to use Desmos to help with my graph. It should look about like that. Again, I eyeballed this knowing that these were going to be parallel. They were going to be parallel because the down payment didn't change. So I'm going to increase by 40 each time, and this one also increased by 40 each time. This was just the original starting at 250 picture, and this one now starts at 400. So I'm going to use Desmos to graph these to confirm. Find my Desmos graph there. I'll have to rescale again. I had A equals 40n plus 240, and the new one, A equals 40n plus 400. So again, I can't really see anything in this window because the y-axis is nowhere near tall enough. I'm going to just jump this up to 2000. Maybe that's a little too high. And I'm going to jump this over to 24. We don't really need the negative and the x's. We'll jump it down to 0. So that is what we wanted to see. I'll zoom it out a little bit. Again, the initial graph crossed the y-axis at 240. That was the down payment when I was just buying the camera. And now it's 400 when I buy the tripod as well. They are parallel, and that's what I was trying to draw on the page as well. All right. So moving back to my book for my last part of the question here. What can you say about the graphs of these two lines? They are parallel. They go in the same direction. And comparing the two lines, what is the same and what is different? They're parallel, so they have the same slope, but they have different vertical intercepts or different y-intercepts. Okay, so the last question, we want to write the equation of a line who is going to be parallel to y equals 0.5x plus 4. So if it's going to be parallel, the lines have to have the same slope, and the slope is the coefficient of x. So they have to have the same slope. So my new line has to be 0.5x plus or minus something that isn't 4. So I can choose whatever I want and make a parallel line. So I'm just going to say plus 6. That could be something different. You could choose plus 10 or minus 8. This part of it's different. The y-intercept part of the equation is different. The slope is the same if you want your two lines to be parallel.